Students, in this video lecture you will be learning what is Thevenin's theorem with the help of an example. Before I start with Thevenin's theorem, I would like to refer to a problem which we have solved while learning superposition theorem. Now that problem you can see here. In this circuit we were supposed to find current through 5 ohm resistor using superposition theorem. So to find current through 5 ohm resistor, what we did is we used Kirchhoff's voltage law and then we wrote two equations for each source and then found current through 5 ohm resistance due to each source. After that we added two currents to get the total current through 5 ohm resistor. And in doing so, we spent around 10 minutes of time. And final result was 1 ampere of current through this 5 ohm resistor. That solution also you can just see here. 5 volt source considered, two equations are written, and these two equations are solved to get current through 5 ohm resistor due to 5 volt source, and that current is 1 by 3 amperes. Similarly, we considered 10 volt source, again wrote two equations and solved for current through 5 ohm resistor due to 10 volt source. That part you can see here, 10 volt source. Again two equations are written. Those two equations are solved to obtain I1 dash and I2 dash. And then current through 5 ohm resistor due to 10 volt source is calculated as 2 by 3 ampere. Finally, the current through 5 ohm resistor was found as the sum of current due to 5 volt source and 10 volt source. Ultimately it was 1 ampere. So this entire solution took a time of about 10 minutes. Now let us say in the same problem, that is in this circuit, if this 5 ohm resistor is replaced by some other value and we are asked to calculate current through that resistor, then again 10 minutes we will have to spend in writing equations and solving those equations and to finally get the current through that given resistor. So that will take 10 minutes of time. Like this, if we are given with 1000 resistors, then we need a time of 1000 into 10 minutes, that is 10,000 minutes. So in such cases, time required to find current in all 1000 resistors will be several hours. But if we make use of Thevenin's theorem to find current in all the 1000 resistors, then the time required may be considerably reduced. How it is possible, that we will see now by solving this same problem by using a Thevenin's. How it is possible, that we will see now by solving the same problem using Thevenin's theorem. So now let us see what is Thevenin's theorem. It states that any linear electric circuit may be represented by a source and a resistor in series with it. Between any two terminals. Such a circuit that represents entire circuit between two terminals by a single source and a resistor in series is called Thevenin's equivalent circuit. Single source is called Thevenin's voltage source and a series resistor is called Thevenin's equivalent resistance. Explanation. Let us consider one electric circuit. In which V1 and V2 are two voltage sources, R1, R2, R3 and R4 are four resistors, whereas between terminals A and B here. Load resistance RL is connected, in which we have to find current. Now between these two terminals, we can have a simple circuit which will be consisting of a voltage source in series with a resistor. Now say this is terminal A and this is terminal B. Between these two terminals, one series resistor and a voltage source. We will find. Whereas this resistor here is called as Thevenin's equivalent resistance and is denoted by RTH. Voltage source here is denoted by VTH and is called Thevenin's equivalent voltage. If I connect here now this load resistance between terminal A and B, I can calculate current IAB as VTH upon RTH plus RL, because it is series circuit now. And here let us say the current flowing is equal to IAB. What current I get here, same current I will be getting here. Now let us take an example and solve it using Thevenin's theorem. Find current flowing through (5 ohm) resistor in the following electric circuit. Here I am considering same problem that we learnt in superposition theorem. So here we have to find current through 5 ohm resistor. Let us assume 5 ohm resistor is connected to terminals A and B as shown below. Now we will solve this problem in many steps. In that, step number 1 is to disconnect 5 ohm resistor and keep these two terminals A and B as open. You can see here, when 5 ohm resistor between terminals A and B is disconnected and kept aside, terminals A and B will become open circuit terminals. In step 2, we will find voltage between or the potential difference between terminals A and B. To find the potential difference between A and B, I will transfer the part of the circuit which is to the right of terminals A and B to the left of terminals A and B. Now circuit appears as shown here. Now this circuit may be redrawn in this way. (4.9 plus 0.1 is 5 ohm because these two are connected in series. 1.1 plus 3.9 is also 5 ohm as these two are connected in series, and here is 5 volt source. Now potential difference across terminals A and B is same as potential difference across either 5 ohm and 10 volt branch or 5 ohm and 5 volt branch. To find what is the potential difference across A and B, we need to find what is current flowing through this mesh now. So mark mesh current I here. Now apply KVL. Applying KVL, here current I and 5 volt source voltage rise direction are same. So 5 with plus sign, whereas current I direction and voltage rise direction of 10 volt source are opposite. So minus 10, that is equal to 5 into I plus 5 into I. Simplifying, we get minus 5 equal to 10I, or I equal to minus 5 by 10, that is minus 0.5 ampere. Minus sign with I tells us here now the direction of current that we have assumed, that is clockwise, is not correct. So we have to reverse the direction of current I here. Reversing the direction of current I will become 0.5 ampere. Now we will redraw the circuit. And we will show current I direction reversed. Now it is anti-clockwise. These are two terminals A and B. Now potential difference across A and B is the same as potential difference across 10 volt and 5 ohm branch. So I can write VAB as $10 because it is voltage rise in this branch, and there is drop of 5 into I in 5 ohm resistor. So minus 5 into I, but we have found the value of I as 0.5. So potential difference across terminals A and B will become 7.5 volt. And this potential difference only we call as Thevenin's voltage source, and we will be using it in Thevenin's equivalent circuit. In step 3 we will find equivalent resistance between terminals A and B by replacing all the sources by their internal resistances. Step 3. Find resistance between terminals A and B. After replacing 5 volt source and 10 volt source by their internal resistances, circuit appears as shown here. Now you can see 5 ohm and 5 ohm are connected in parallel. So equivalent resistance of 5 ohm and 5 ohm will be now connected between terminals A and B. What is the equivalent resistance of 5 ohm and 5 ohm? RAB equal to 5 into 5 divided by 5 plus 5, that is 25 divided by 10 equal to 2.5 ohm. So here we are having now 2.5 ohm, and this is nothing but Thevenin's equivalent resistance. Now we will draw Thevenin's equivalent circuit. Now write step 4 here. Draw Thevenin's equivalent circuit. What it will be having now? It will be having Thevenin's voltage source and Thevenin's resistance between terminals A and B. VTH equal to 7.5 volt, RTH equal to 2.5 ohms. To find current through 5 ohm resistor between A and B terminals, we have to reconnect that and then calculate the current. That we'll do in step 5. Reconnect 5 ohm resistor between terminals A and B and calculate IAB. So what we'll be having here? Thevenin's equivalent circuit between terminals A and B. VTH equal to 7.5 volt, RTH equal to 2.5 ohm, terminal A, terminal B, and now I am bringing here 5 ohm resistor which we disconnected in step 1, and this is nothing but our load resistance, because in this resistor only we have to find current. I will write IAB equal to VTH divided by RTH plus RL, that is equal to 7.5 divided by 2.5 plus 5, which is 7.5 by 7.5 equal to 1 ampere, and same result we had obtained when we solved this problem using superposition theorem. Now coming to time efficiency of Thevenin's theorem. In Thevenin's theorem, we found VTH, RTH, and then IAB. Time required to calculate VTH. Say we have taken 10 minutes. Time required to calculate RTH. Say we have taken 5 minutes. Time required to calculate IAB. Say we have taken 1 minute. In total we have taken 16 minutes. If we have to find IAB for different 1000 register values connected to terminals A and B, then these calculations we will not have to repeat. These will remain as they are. Then I need not have to calculate VTH and RTH. That means these times are fixed. Only for 1000 registers I have to calculate IAB. So 1000 into 1 will become 1000. 1000 plus 10 plus 5. The total time required will be 1015 minutes. For calculating current through 1000 number of RL values we need 10 plus 5 plus 1000 into 1 equal to 1015 minutes. As I told in the beginning, if I use superposition theorem to find current through 1000 number of RL values, then time required will be 10,000 minutes. Time required to calculate current through 1000 number of RL values using superposition theorem will be 10 into 1000 will be equal to 10,000 minutes, because for every value of resistor to find current I need 10 minutes. So now you can see, here you can see, using Thevenin's theorem we need approximately 1000 minutes of time, and using superposition theorem we need approximately 10,000 minutes of time, which means that Thevenin's theorem is very faster method of computing current through large number of resistors connected to same terminals. So this is what we have to understand. So we need to understand this advantage of using Thevenin's theorem when we have to find current through large number of resistors connected to the same terminals of a same given circuit. I will stop the class here.